Okay, welcome to the intro video to the package called Dichotomous Key. This package is written in R to manipulate dichotomous key table for classification in biology. So before running into the package, here's a very brief introduction to what a dichotomous key is. So the dichotomous key table, the dichotomous key list, it's a data structure that asks you a bunch of questions in order to classify what species the certain organism belongs to. So, for example, uh, to like to classify certain mammal, I could start with is it a is it like an animal or is it the plant? If my answer is it's an animal, I go to the second question, which asks you some more specific details about the organism. For example, does it live on land or does it live in water? So I want to classify myself, so I live on land, or does it have fur, or like does it have like our normal skin, or does it have feathers? So it's live on land. Here's the third question, and I can classify myself as a mammal. So this one is a very simplified example to show you how the data structure work. But to actually store this information into a computer or into a graph, you have to build like certain like tree-like data structure like this, because for each time you come up with a more specific question, you, you will have to store the new question as the subnode of the previous question and record where the node come from. And in this way, the data structure can get more complicated. Um, but the good thing about this is that for each time you ask two questions, and the by suppose the number of questions I ask is n, and the and the number of the number of outputs, so the number of the species being classified can expand very easily by 2 to the power of n. So if I have n questions, so in terms of computation complexity, you need you can classify 2 to the power of n species or subspecies or like that in maximum. Uh, and so to do the reverse transformation, you could use log. So if I have k species, if I have k species, I like k could be larger or a lot larger than and if k is really large, you don't want to look at every species and like look at the tables and see what the organism is. But if you use the dichotomous key table, I could have log 2 k questions, and it's worthy to know that this can be much smaller than this. However, the to be able to ask these questions, every node has to be stored, so the table gets really large, and it's really hard to manipulate them by hand. And especially if I have a tree-like structure, say here's my first dichotomous key, And I want to further classify some species to down to another level, and I have another species. If I store them as list, that's still all right because now in modern computational language you have the data structure that handles the list, but in the form of table it can be really hard. So I made a program to address the problem, and it's not very modernly advanced algorithm you can use, but some really simple functions that you could call. So I will start from, okay, let's start from installation. I think that's shared. Okay. So does it work? Mm, okay. So to install the package, you just use library uh, DevTools. If you don't have DevTools, I highly recommend you install this because it lets you install a lot of packages in development and a lot of experimental packages on GitHub and let you do all kind of testing and package publishing things. And I could use DevTools, and there's a function called install from GitHub. Oops. So and it follows the form developer and the package name. So right, and load the package by using library or require. So the page comes with two minimum example to test your code before working on real dichotomous key data. First one is called DKEG, and the second one is DK of birth. They are really really simplified, and please only use these dichotomous key table to test if your code runs, and don't use them as a real data, right? So the first function is of course classify, but different from other usages. If I want to store the result, I could say uh, my organism, not my organ. Okay, let's just do my is classify. Sorry, it's called dichotomous key classify, and it takes in a bunch of parameters. In this case, I want to classify with this dichotomous key table. And just like what we've written on this sheet of paper, the this works like exactly if one is looking up a table. So I'm an animal. I live on land, and I'm a right, and I have hair, so I'm a mammal. So that's quite easy, and I could load my result from this. But uh, there's a lot more information we can extract from a dichotomous key table. For example, given a species, what characteristic does it have? So to use this, we can go dk extract. This means extract some phenotypical characteristic from a given species. So I can take in my example and see what probability does a mammal has, or you could just use the variable here. So extracting is animal-like, it lives on land, it has hair. Okay, I have a what if I have a fish? Okay, it shows me it's animal like it lives underwater. Okay, and to visualize this, it's quite easy to convert the dichotomous key table into a list. So this list is not very pretty, but it has the structure like a tree-like structure, like what we have drawn here. Okay, and uh, it's not a recommended way of viewing list, though. It's just to give you a bunch of intuition. And say, so in the previous example, we showed that DK bird is also a economist key table. Uh, but here's an interesting thing. My first example table has a row called a bird here, and can I append this little dichotomous key into the larger network? And the answer is quite simple. We use DK append. So I want to append something onto something. I want to append DK bird onto DK EG and append to bird. So it automatically give me a new tree. So I can save this data. Say this is my new dichotomous key table. And to use this, it follows the same property. So I can do DK extract, maybe extract um, DK new, and then this I want to see maybe some more specific species like right. Oh, sorry, I did. I think I made a bit of mistake there. This is bird. This is species. Okay, so that's in the correct order. Okay. All right, it's appending this my new species, and I can go DK extract, and using my new dichotomous key table and my typical target is somehow, for some reason, called small bird, and by using this, I can extract all the phenotypical properties that this dichotomous key table gives like with a small bird. So a small bird, first of all, it's a bird. It has feathers. It's a land animal. It breathes on land, and it's animal-like. Okay, if you right, so that's quite simple. But there's some more complicated scenarios. For example, if I have a large tree table like this, let's just focus on this one, and uh, in some way, I only want to classify from certain father nodes. So this is called a father node of tree, uh, but of course, it's a CS. This is a computer term. It's so. I can actually partition this dichotomous key into two parts. First, I don't really care about this part. I only if I only want to classify from some subspecies. For example, instead of knowing this is an organism, I already know this is an animal, or I already know that the certain thing given is a bird. I could have a dichotomous key table extracted from the bigger dichotomous key table that only has these entries, so that it's not only easier to store, but also easier to manipulate. I could do dk partition. Okay, and from my dk new, I can have a subtree called animal, and I would save this dk animal. And we can see what this is. So this extracted dichotomous key table has no redundant nodes, right? It only has properties of animal. But what this doesn't give is a table that with the ID of the father node starting from 1. So we can reduce it. That's quite simple, and I can do I can use this as just like a normal dichotomous key table with no problem. Sorry, but when we do this, it's better to assign this to the same value, and I can classify from there. It works like exactly the same way. All right, so that's not a very interesting thing. Some further implications says that we could judge if a species belong to a group of species or a class by using the partition of the dichotomous key. But actually, if you think of this structure as a tree, so if I want to see if I have one species, let's say if I have one organism as this, and I want to see if this one belongs to this, actually I don't have to partition all of this. The way the way to judge if a species belongs to a certain class is just go along of it's just go along with these edges with a direction. So I made another function called dk is well, this is an overly simplified name. If one thing is another thing. So if so tell me if a mammal is an animal. Okay. Okay, and starting from this, true. All right. So is bird an animal, right? And similarly, that would be false, right? And also that's quite simple, but to the reason I used dk as the entry of as an entry of nearly every function in this package is that you almost always want to specify which the dichotomous key table to use, not only for the simplification for the computer to handle less data and handle them faster, but also if you have a conflicting dichotomous key table, you could actually compare them. So that one species is classified as in certain way in one table, but it could also like this result could conflict with the dichotomous key table from another document. So when you use those functions, it's always useful to specify which standard that you're using for the classification. Okay. All right. So the last thing is how do I get a customized input of the dichotomous key table? So it is it is easy to create a file, for example, a CSV file, or you could just export from Excel or other spreadsheet spreadsheet things, and I could read it uh, using that. Okay, and this is of course I can't show the data because I haven't got the copyright for this. But this is the way you can import a table, and the form of the way you formulate the Dichotomous Key table uh, is also quite easy. The first column is the ID of the father node, so it's the ID of the question that the program asks. The second column is some properties or phenotypical properties. So they what does the species look like, or how do you classify that this belongs to this branch? Okay, the third one is it's more about genotypical. It's more like a name of the species in general, or in common, like in plain English. Um, the last column is the reference. So so when the program asks the first question, if the user say it's a plant, go to this reference, go to two. So the program in turn finds two. Okay, that leads to this question, and it ends there if there's a zero in the reference column. Uh, but it could continue. Like if the user signs as animal, go to three, and then ID of three. Then in question three, there's a just like a question: Does it live underwater, or does it live on land? If the organism lives on land, go to four. And in this way, the dichotomous key table doesn't have equal length of question for each ending point of the nodes. But that's all right, because sometimes it happens that we just need a different number of questions to classify to different species. Okay, so thanks for watching, and if there's any issues or suggestions, please feel free to create a issue or create a bug report on on my GitHub. By the way, the GitHub repository is just github.com and this. Okay.